We can also perform lots of statistical operations in NumPy arrays really efficiently as well. We can find a single mean value across the whole array just by saying name of the array dot mean, and that's it. It'll give you the a mean across all the values in your array really efficiently. Again, there's only 5 numbers in this one-dimensional array here. Imagine millions of numbers. Okay. And so that you can see this works for a one-dimensional array here, and in the second array, it's basically taking a mean across all of the values here. If we don't want to find a mean of all values across all dimensions, we can be a bit more specific than that. So we can find means across different dimensions of the array. So if we said np.mean and then pass in the name of the array, and if we say axis equals 0, that means give me the mean across rows, i.e., in this case, the 2 lists. So that would say, give me the mean of element 0, the mean of element 1, the mean of element 2, etc. So here, if we can work this out. So that's saying the mean of 1 and 6. Okay, so that's going to be 3.5. The mean of 2 and 7. That's 4.5. The mean of 3 and 8. So what will get returned here is an array itself, each of which has a mean value. Or we could do it the other way around and say we want to take the mean across columns. That will give us axis equals 1, will give us that, which gives us effectively the mean of each row. So what's the mean of this group and what's the mean of this group? So here we get the mean of this group is 3, the mean of this group is 8. Again, think back. Let's imagine these are groups of individuals. The mean of ages here, pretty young group, but the mean of ages here is 3, the mean of ages here is 8. Okay. And again, as ever, you use the same syntax for 2, 3, 4, 200 dimensional arrays, whatever it may be, and the axis the value would simply increase. Again, don't worry if your head's starting to hurt. That's why I'm showing it to you using these simple, easier to understand arrays.